Hi folks, this video is about cofunctions, which is really about how the sine of one angle and the cosine of another interact in the special relationship that they share. All right, I'm ready to jump right in here. In part A of example 1, it says write expressions for the sine and the cosine of angle A. And I'm just going to refresh your memory. Sine is the opposite over the hypotenuse. Cosine, remember, is the adjacent side over the hypotenuse. Tangent is the comparison between the opposite and the adjacent. So sine of angle A is going to be what I get when I compare the side opposite angle A, so in other words, leg A, over the hypotenuse, which in this triangle is C. The cosine of angle A, remember, is going to be equal to the comparison between the side adjacent to angle A, so in this case B, and the hypotenuse C. To write those same trig ratios in part B, I want to do now cosine sine of angle B, which is going to be side B over side C, and cosine of angle B, which will be A over C. And what I really want to pay attention to is this relationship here. Notice that the sine of angle A and the cosine of angle B both compare the same sides of the triangle and are therefore equal to one another. Likewise, cosine of angle A and sine of angle B also compare the same sides of the triangle, and they too are equivalent to one another. So in part C, do you notice a relationship between any of the ratios written above? For simplicity's sake, I'm just going to compare one of them. I'm going to say the sine of the first angle, angle A, is equal to the cosine of angle B. And we know we live in New York State, and we know that in New York State, they love to ask us to justify or to explain why something is true. So as to why this is true, both of these trig ratios compare exactly the same sides of the triangle. Now I've heard some students say that when I do sine, it's opposite over the hypotenuse, and so this the side that's opposite angle A is the same as the side that's adjacent to angle B. That's a totally legitimate way of thinking about it. It's a slightly different way to phrase it, but again, both of those ideas have the fact that trig ratios are comparing the same side of the triangle. So the big idea that I really want you to take away from this video is that the sine of any angle is always going to be equal to the cosine of its complement. Those two angles, A and B, live in the same triangle where one of the angles is a right angle, meaning that the remainder of the two have to add up to 90, making them complementary. So you're really going to see two different types of problems for cofunctions. You're going to see a type where you see sine and cosine on opposite sides of the equal sign, like in number 1. Notice that on the left side I see a sine, on the right side I see a cosine. Well, if one of those is sine and the other is cosine, I know that the two angles involved, in this case theta and 15 degrees, must be complements. Complements, remember, means adds to 90. So theta plus 15 has to add up to 90 degrees. And that'll make theta equal to 75. So number 2 is kind of similar to that, where again, notice that we see sine on one side, cosine on the other. We know that those two angles that follow the sine and the cosine have to be complements of each other. So in letter A, I would do 90 minus 42, which makes this guy 48, because the sum of those two has to be 90. In letter B, we're talking 78, because again, the sum of our two angles has to be equal to 90. And in letter C, what goes in that blank is a 45, because again, the sum of those two angles has to be 90. Example 3 is just a slight variation on that. Again, notice that on one side of the equal sign we have sine, and on the other side we have cosine. And if that's the case, we know that those two angles that we're working with have to be complementary, or in other words, have to sum up to 90. So I can write a little equation here that says the first angle 3/4 x plus the second angle 1/4 x has to total to 90. 3/4 plus 1/4 is of course 1. So 1x, or just x, ends up equal to 90. Moving on to letter B in exercise 3, I have the same idea where I have sine on one side of the equal sign and cosine on the other side of the equal sign. If that is true, I know that the two angles that are being referred to must be complements, or must add up to 90. So the first angle, 5x minus 22, plus the second angle, x minus 10, must have a grand total of 90. So when I combine like terms here, 6x minus 32 equals 90. Adding 32 to both sides tells me that 6x's are equal to 122. Then lastly, dividing both sides by 6 gives me a fraction in simplest form of 61/3. I could do that as a decimal if I want to, but it ends up being a repeating decimal, so I think I'm just going to leave it as a fraction. So that is the first type of question that you might see in this topic, the type where you have sine of one angle equal to cosine of another. And the real takeaway that you need to know there is that when that occurs, the two angles must be complements, or add to 90. Example 4 is a little bit different here. We don't have sine on one side of the equal sign and cosine on the other. But rather, what we know is that the sine of the first angle in the triangle is equal to the 2x minus the 3/10, and that the cosine of its complement is equal to the 4x minus the 1 2/10. Well, what I want you to remember here in this case is that the angles that we're looking at are the acute angles in that right triangle. The sum of their measures must add up to 90. So the measure of angle A plus the measure of angle B must be 90. And if those are complementary angles, then when I find the sine of angle A, that's going to be equal to my A over C. The cosine of my angle B is also going to be equal to my side A over C. And I know, therefore, that the ratio that compares opposite to hypotenuse for sine of A is going to be equal to the ratio that compares adjacent over hypotenuse for angle B. So in other words, the sine of angle A is equivalent to the cosine of angle B. But now, using a little bit of substitution, the sine of angle A has a value that's 2x minus the 3/10. So into my equation, I'm going to replace sine of angle A with the 2x minus 3/10. The cosine of angle B has a value of 4x minus the 1 2/10. So I'll replace cosine of angle B with the 4x minus the 1 2/10. And now I've got an equation here that will allow me to solve for x. So I'm going to start by subtracting 2x's from both sides, but that is not the only way that you could go with this. I'm then going to proceed by adding 1 2/10 to both sides, which tells me that 2x's are equal to 0.9, And a little bit of division to finish this off tells me that the value of x is 0.45. So I'm going to end this video by reminding you that if we're looking at angle measures are always complementary. They always add up to 90 degrees. If we're looking at trig ratios on the other hand are always equal. So you really have to think critically about each problem and ask yourself, what is it that I'm looking for here? What is it that x is part of? If it's part of an angle, sum them to 90. Part of the ratio, set them equal. All right, as always, thanks for the gift of your time. There are some check your understanding questions in Delta Math to take a look at, so make sure you have a good time with those. And as always, if you have questions or need to clarify your understanding, bring those with you to the next time we meet in class. All right, take care. Till we talk again. Bye.